question 4 kicks it up a notch because this time we've got a cubic, but we can sketch them fairly easily. We've got the line y equals 3 take x. So that's a straight line, negative gradient, like it's going downwards, and its y-intercept is positive 3. We've also got the cubic, y equals x squared, take 5x, x cubed, take 5x squared plus 6x. Now I don't know how to sketch that straight away, but I do know that x goes into all of it, so I'm going to take it out the front. X squared, take 5x plus 6. Now this is a quadratic, I do know how to factorise that. What multiplies to give positive 6 that adds to give negative 5? Take 2 and take 3. So that's a cubic with intercepts 0, positive 2 and positive 3. So if we now sketch these, again, not doing an amazing job, and technically I don't actually have to find the zeros every time, I just like to. So 3 take x means we're going down like that, y equals 3 take x. Cubic goes through 0, 2 and 3, and we're going, like, I'm assuming that it's going to hit at 3 points. I wish I'd drawn this better. Let me do this better. I'm drawing the worst case scenario. So the worst case scenario has it hitting at 3 points. So I'm going to call these alpha, beta, and gamma. Okay, so now they've asked us to show that it equals each other, like the normal first step. So 3 take x equals x cubed take 5x squared plus 6x. Get everything over to the right. I just like to get everything over to where the biggest power of x is. So we've got 0 equals x cubed, we're plussing, there's no x squared, so 5x squared. We're plussing x on, 7x, and we're taking that 3 away, take 3. Good, we're there. Okay. For B, we want to show that x equals 1 and x equals 3 are roots of the equation. So so we know y equals x cubed take 5x squared plus 7x take 3, and it has roots alpha, beta, gamma, yeah? Well, they're saying x equals 1 is a root, so let's put that in and see if they're right. So y equals 1 cubed, take 5 times 1 squared plus 7 times 1, take 3. So y equals, put that in your calculate, 1 take 5, negative 4 plus 7, 3 take 3 is 0. Therefore, x equals 1 is a root. We're going to do the same with x equals 3, y equals 3 cubed, take 5, 3 squared plus 7, 3 take 3. Chuck it in your calculator. What's that? 27 take 45 plus 21 take 3. Yep, it's 0. Therefore, x equals 3 is a root. So use the sum of the roots to find the third root. So for cubics, adding them together equals minus b on a still. So b in this one, we've got minus negative 5 on 1, so 5. We know two of our roots. We know we've got alpha equals 1, beta equals 3. We just need gamma now. So 4 plus gamma equals 5, so gamma equals 1. Ooh, we have a repeated root. We have a repeated root at x equals 1. Very cool. I like that. Explained by why the line is tangent to the cubic. So this is actually why. See. Because we have a repeated root of multiplicity 2, so that's when it repeats twice, not 3 times. So alpha equaled 1 and gamma equaled 1. The line y equals 3 take x is tangent to y equals x cubed take 5x squared plus 6x at x equals 1. So they've now asked us to find the point of contact. So this is where x equals 1. We want to know what y equals. And we want to know the point, how do they phrase it? The other point of intersection. So other point of intersection, which is where x equals the other one, which was 3. We want to know y equals. So the easiest way to do this is to chuck it into y equals 3 take x. So y is 2, so the point is 1, 2. Here, again, it's easy to chuck it into 3 take x, so y equals 0. So the point 3, 0, which we actually saw in our first sketch. That's this one. We just didn't see that the line kind of hits it and bounces back off instead of having 2 separate intersections there. That's question 4.